when you first hear the question, the whole idea about going this seems to be very vague or ambiguous because, right, these are two very difficult shapes to compare. And so the first step you do is sort of turn these shapes into something simpler. And so when it comes to a ping pong ball, I'd say it's about a cube, right? It's sort of pretty similar enough, right? Where you're not losing that much of the volume. And then when it comes to the airplane, we can say that it approximates a rectangle or a 3D rectangle. Right, so now we've gone from very ambiguous shapes to very simple to calculate shapes. And so the first thing you do is try to measure out what the dimensions are for each. And so I know the ping pong ball is pretty small, and so we can say it's about 4 by 4 by 4 centimeters. All right, so that's for the ping pong ball. And then the airplane's a little harder. But I know when it comes to length, a typical commercial airplane is about 40 rows. And so I know when I sit down in a seat, I can extend my legs. There's some wiggle room. So we can call it about 2 meters per row. That gives us 8,000 centimeters because it's 2 meters times 40, 80 meters, and then we have 8,000 centimeters. Then when it comes to the length, we know there's a middle walking path. Then there's, for the typical plane, there's about 2 seats to the right, 2 seats to the left. And so, given about how I could probably lay down across the seats, and I'm about 2 meters, I'm about 1.8 meters. That gives us about, if I were to approximate it, it'd probably give me about 6 meters in terms of width, right? So then there's that. So then we have, 600 centimeters here. So then we have the width and the length, and now we just need to calculate the height. And so I know there's about 2 different heights when it comes to the airplane. There's the middle walking path, and then there's the luggage on the right and left that sort of cuts into the height of the seating area. And so I know when I'm walking through the middle, there's an ample amount of space above my head before I sort of hit the roof. And so knowing I'm 6'1", so about 1.85 meters, we can say that the middle path has about 2 meters of height. So that gives us 2 meters down the middle. And then I know when I sit down and sort of try to stand up in the seating area, my head sort of hits the top of the roof of the plane. So we could sort of call it 180 centimeters there. All right, so now that we calculated the dimensions of the plane and the dimensions of the ping pong ball, now we just have to calculate the volumes and then divide the volume of the plane by the volume of the ping pong ball. That will give us the number of ping pong balls that fit in the plane. So when it comes to a ping pong ball, this is pretty simple. 4 by 4 by 4, that's 64 centimeters cubed. Then when it comes to the plane, we'll just have to do some math here using some quick assumptions that will allow us to quickly get an answer that approximates the volume of this rectangle. So we can do length times height for each of these slivers. That's 8,000 times 180. And then we know 8 times 180, 8 times 18, is 144. Count out the zeros, call that 1.44 million centimeters squared. And then using the same trick for the middle path, we got 8 times 2, 16. Count out the zeros, and then that's about 1.6 million. So now we have these areas, and then we just multiply these areas by the width. So that's 600 times 1.44 meters. 1.44 million centimeters times 600 centimeters, and we can call this about 1.5 million, right? And so now when we convert this to 1.5 million, it's much simpler to solve, right? Because we do 1.5 million times 6 is 9 million, and then you add up the zeros, 900 million. So that's the volume of the 2 slivers in the left and the right. And then you just do something similar for the middle road. That's 1.6 times 6, 9.6. Count out the zeros, and that gives you 960 million there. And that's just one. And then you just add these up, 900 times 2, 1.8 billion, plus 960 million, that's 2.76 billion centimeters cubed. Then we have the original volume of the ping pong ball, we have the volume of the airplane, and now we just gotta divide it out. And one quick assumption that we could do is call this 3 billion, right? 3 billion. And call this about 60, right? So now we have numbers that are very easy to divide. 3 billion divided by 60, we can just do 300 divided by 60, that's 5. And because we just removed 300 by dividing it by 60, all we have left is the million. We have left is a million. So that's just 50 million. All right. Sorry if we did